off, and I'm actually very excited about talking about WebSockets and a few other tricks. So the talk title is Getting a Better Night's Sleep with State Machine and WebSockets. So it is Laura Kalbag.
Thank you. Yeah, that looks like me. When I moved to Kilkenny a few years ago, I never thought I'd end up speaking at a tech event in Kilkenny. It seems very strange to me, so thank you very much for having me. In opposition to Gil's talk, I'm actually going to be showing you very little code, and that is part of the point. First up, I need to make sure that the audio is plugged in. Where is the audio jack? Aha, got it. You'll see why later, but I'm going to check it quickly. So this is Oscar, and the audio is working. Excellent. So my name is Laura Kalbag, and I'm going to talk to you a lot about state machines, a little bit about WebSockets. I wanted to make sure that I had a demo that was relevant for all of you folks. And I'm going to talk to you about state. So let's start off with some issues that we have around state management. So we start off with just the complexity in general. The bigger the app, the harder it is to manage state. Even the smallest feature that you add can increase the complexity an enormous amount. We have data flow, so passing state between components can get really hard to follow where the data is moving around. It can get very complicated. We have concurrency. When different components are interacting with the same state simultaneously, you can get into very tricky situations. And we also have testing and debugging, because the more states you have, the harder it is to isolate and reproduce your state-specific issues. So let's be honest, a lot of the time, the sum of your app logic is essentially stored inside some engineers, or maybe multiple engineers' heads, and it isn't really easy to communicate the stuff that's in your head, especially if someone goes on holiday, someone's out of office for the day, someone even quits. And this will end up causing you a lot of sleepless nights if you're just trying to work out how does everything work together. So my original demo that I did for this talk was around a white noise machine. And the reason I did this was because we have a dog, and which you saw at the beginning, Oski, and he's terrified of fireworks. And if you're not from around here, you won't know, but especially around Halloween, people love to set off fireworks. And we ended up getting a white noise machine. If you've got babies, you might use these as well. A really cool little physical device that you could put on, and it creates this really lovely, soothing sound. But a white noise machine is kind of a one-person personal experience. It doesn't really work for a room of people, and it doesn't really work for real-time demos, which is what I want to show you today. So I was inspired by Max Richter's Sleep. I don't know if anyone is familiar with Max Richter's Sleep. Yeah, it's this really cool, it's an album that you can listen to, music-wise, but the demo that he did, he created all of these layered, soothing sounds and a lot of choral arrangements and things like that. Luckily, I will not be doing any singing today. And live, he actually performed it in London with a bunch of people, and the whole idea was that they lay down in bed and went to sleep. So I thought, okay, this is a fun idea for a demo. Maybe not good to be encouraging you to go to sleep at this time of the morning, but maybe after last night you feel like you want to. So I'm going to build a soothing, collaborative sound machine. And I'm going to think about what the state situation might look like for this machine. So this is my very messy handwriting. I apologize for this. So I've got a sound. So I might have the on and off for the sound. I've got play and pause. Multiple sounds, maybe. Random audio, maybe. Maybe that will make up for my lack of musical arrangement skills. Color. I always like to have color involved. I went to art school, and I didn't study computer science, so this will explain a lot. So I want to have some color in there, black and purple and blue maybe, toggle between them. And players. So this is going to be the real-time aspect of it. You are all going to be my players, and maybe when people join and leave, I'm going to have what is essentially a kind of counter, but I'm going to make it stars because I think that will be pretty. And of course, this is already getting quite complicated, the way that all of this state might interact. And so, of course, what tool am I going to recommend? State machines. So who here knows about state machines already? Yeah. And who here knows about state machines because they studied it in computer science? Yeah. And does anyone actually use state machines now? OK, cool. How many of you use XState? Yeah, that's good to know. OK. Hopefully a lot more of you will later. So this is a finite state machine. This is the example that you find when you look up finite state machine on Wikipedia or something like that. But I actually adapted it because it was originally a coin-operated turnstile, and no one knows what that is anymore because we don't use them. So I adapted it slightly helpful for our example. So the idea behind a finite state machine, it's a visual representation. You have paused is a state, playing is a state, and then with input, you can transition from one state to the other. So with the play event, we can transition from the pause state to the playing state, and then if we have a pause event, we can transition from the playing state back to the paused state. A very important concept is this weird-looking symbol here, and this is the symbol that identifies the initial state. So this is like a sort of blob with an arrow coming out of it that points at the initial state. So that tells you when your state machine is run, you start with that state. So state machines are an excellent visual representation of what your code should be doing. So I'm going to create a state machine for my sleep app, and I'm going to do it visually. Before I get to that, I'm going to say that despite the front-endiness of my example, I started out at art school, as I said. I'm often more in the front-end side of things, and so I tend to lean towards pretty demos, things that look nice and do fun things. That's not me saying that the backend isn't pretty, but so it makes a cool demo. I will show you some backend examples later, I promise. So here is my initial state, and I am going to make that into off. And then I'm going to have an event that's just a toggle the sound, and that's going to toggle to the on state. And then I want to go back, an event that goes back from toggle sound, so on to off. So that is a very simple state machine, very much like what I just showed you. Now I'm going to add actions. So these are your fire and forget side effects that you have. So I want to randomize the audio. So I'm going to add on my on state, I'm going to have an entry action of randomize audio. So that's saying that when we toggle the sound on, it's going to fire off randomizing our audio. So far, this is a very finite state machine. Now, I'm going to behold the power of the state charts. So state charts are a visual extension to state machines, and they allow us to model a lot more complex logic in a way less repetitive way. So these are the on-off states. They're going to all belong to a sound state. So I'm just going to copy them and make a little sound state. And there we go. So inside, I've got these child states and a parent state. So my parent state is sound, and then the on-off states are inside of that. So magically, we now have hierarchy. That's not something supported in finite state machines, but you can use them in state charts. So this is going to reduces all the repetition. That's a bit of a tongue twister there. We also have, in state charts, parallel states or concurrency. So because now I have a sound state, I'm going to add my player state. And I'm also going to add my colors state, color, spelling it correctly as well. And all of these states, I'm going to change the parent state into a parallel state. And now there's no errors. All of these states can be active simultaneously. I'm going to also do a here's what I did earlier and just put some, it's another set of toggles in my color state. So that's toggling between the black color, toggles to purple, toggles to blue. And we fire off updating the color on each of those states. So all of these will work concurrently. Now I want to show you self-transitions. So these are events that can be fired off and then return back to exactly the same state. So I'm going to add on my player's state. This is a very straightforward little state. And I'm going to add an entry action that is update number of stars. And I'm going to add a self transition for when a player joins. And call that player joined. And that is going to fire off an action of adding a star. You'll see what all this stars nonsense is about in a second. And another self transition for when my player has left. And that is going to be removing the star. Now, the demo that I have doesn't actually have any conditional logic in it, but I know that people love to see examples with conditional logic because we use them all the time. And for this, we use guards. And so guards will guard against those conditions. So I'm going to add a really silly example here. Perhaps for my colors, you're only allowed to access the purple color if you have some sort of special status that you're a superstar. It's very grown up, but it was what I could think of. So I'm going to say if I superstar, and that will then transition from black to purple only if superstar condition is met, and else I'm going to transition straight to blue. So you can only toggle between black and blue if you're not a superstar. So who here has heard of the actor model? I guess if you're a fan of event-driven architecture, you're probably going to have heard of it. And so the actor model works really well with state charts, because the actor model is where everything in your system is an actor, and an actor can send and receive events and change its behavior based on those events. So it's quite a clean way of architecting things in an event-driven way. And this helps us make all of our logic a lot more modular and maintainable by breaking it into those actors that can communicate with each other. And basically, whenever a state chart is running, it itself can be an actor. So I'm going to add a little actor here in my demo as well. So first of all, I'm going to remove that silly guard because it won't do anything in the demo. And then I'm going to add an actor on the sound. Something like an audio player, it's really useful to have things like that as a separate actor so that you can update them and change their functionality without having to change the rest of your logic. So I'm going to invoke an actor on my sound state, and that actor is going to be called audio player. Bad at typing. There we go. And I'm going to give that an ID of audio player as well. That's important for the next step. And then when I hit my on state, I'm going to have an action that is fired off. It's going to be a send to action. This isn't a custom XState action. Talk more about that later. And to the audio player, that is going to send an event of play. And when I get to the off one, surprise, surprise, the entry action for that is going to another send to action. To my audio player, I'm going to send pause. It's not stop because it's the web audio API and it likes play and pause. It doesn't really do stop. I made that tidy. Very nice. Now, having a state chart like this that is also executable code means that you can simulate the logic for your machine as well. So first of all, I'm just going to make this a little bit tidier so we can see it all a bit better. This is the problem that when you study design, you become very fastidious about diagrams looking neat and tidy. And there we go. Means I can make it a little bit bigger. So now if I go to simulate my machine, now you can see I've got all of the blue are the possible events that I can hit from the current state. I'm just going to move that away. But now you can see I can toggle my color and simulate going from the black state. I can toggle the player left and player joined, won't actually do anything. And on the sound state, I can toggle between on and off as well. And these are all working concurrently. And it makes it a lot easier for you to check before you actually get to plugging everything in, whether you have any unwanted transitions or any unreachable states. So now, I want you to try out the demo. So here's hoping this works and the internet plays well. The QR code will take you to laurakalbag.github.io/collaborative-sleep-sky, and I'm going to do it as well. So there we go. We've got some nice stars there. Oh, yes, sorry, I was too quick. Let's get the mouse back on the other screen. Here we go. There we go. We good? We got it? Oh, all right, there you go, Katie. You can use the URL. That's laurakalbag.github.io/collaborative-sleep-sky. Now when I go to the example, hopefully you'll all be there already. So there we go. Oh, 64 stars. So now, do you want to try turning your sound on? And hopefully, if the rest of you start turning your sound on, and put the volume up as well, we got ourselves a nice sort of soothing live experience. You can also toggle the color as well. The color is unique to you, so you can have whatever color you like. Okay, blue. And there are currently 69, 68. Oh, you're all children. I can see what you're doing. Who's getting their extra devices out? Classic. And so we've got the concurrent behavior happening. You can toggle your sound, you can toggle your color at the same time. It's not going to cause any issues. We've got the when you join or when you leave, it adds a star and it removes a star. It's a fairly basic system right now. It's not, you don't really have a star each, it just looks like it. It's just counting you. But you can control that all yourselves. So now I've set myself a thing where everyone has noise on. I've got to hope that you will all turn it back off again. Or you can keep it on, it's fine. It's like a nice background noise to have going on, I reckon. So I mentioned WebSockets in my talk description. So where are the WebSockets? And while I really wanted to impress upon you the wonder of the state charts, I wanted to help you know how I went from the state machine to a live updating app. And it was actually pretty quick. So what I didn't show you before is that I deployed my state machine as a running actor. Now this is using Stately Sky, which isn't out yet, which explains the basicness of my demo, but it'll be out very soon. And it takes a second to deploy the actor. And then I get from that a URL. I have an API key as well, and a URL. So what this does is it deploys the actor to Stately Sky. And I import that actor into what I've got is a JavaScript V app. I'm using TypeScript, thanks to Josh, who taught me all about TypeScript recently. And using the Stately Sky SDK, I can use that URL. And what that does is I can create an actor from that. And I import that actor into my JavaScript, oh, getting too ahead of myself. So I import that actor into the app using Stately Sky. And so that fetches the machine config from Stately Sky. And then using XState, I can use event listeners to send events to my actor. So actor.send is a method that's provided by XState. And XState is a state machine's library that runs anywhere that JavaScript runs. So you can use it full stack. And then I can send events and receive state from the live actor in real time, which is powered by PartyKit underneath, which orchestrates our state and does the sending and the receiving of the events using WebSockets. And PartyKit runs each actor as a web server. So each Sky actor runs on a durable object inside of Cloudflare's edge network. And that allows for our lovely stateful serverless functions. So as I said earlier, state charts can be used anywhere in your stack. And so hopefully you can now see the potential for state machines for workflows. But here are some backend workflows. I basically hit up my backend engineer friend and asked him for some good examples. So I blame this to some degree on him. But here is an event-based actor. So this is a common example of where you might have container environments where some of your services, also known as actors, may not be exposed via like a resource URI, and instead they're accessible by submitting an event to the underlying container events manager, And so you can do that with a very straightforward sort of two-state, two-event situation. Here is patient onboarding. This is, for some reason, very popular, particularly in places like the US where you have like health insurance and things like that. But this is where we might want to invoke 3 services or actors simultaneously. And so you can have all of your success and error handling in there as well. And here is a serverless workflow where you need to integrate with an external microservice to perform a credit check. When the guy I work with sent this to me, I was like, Gavin, this is so typical. You're in the US, so you send me a credit check workflow. So through this demo, you might start thinking, wow, this is so easy to understand. Like, even the people on my team who don't code might understand what I'm working with. Even the person who's a bit slow in the corner might understand this. And this is because diagrams are great. I told you that I come from an art school background, and this is one of the things when I moved from design to engineering, is the value of being able to represent things visually. Because there's a visual representation of your code, which helps with much clearer communication. It's also really easy then to collaborate with folks, whether they write code or not. And it also makes it incredibly easy to spot errors, which is great for your documentation. And all of this helps with much better planning and organization. And state charts provide all of the benefits of diagrams, but as executable code. So having your application logic be both visual and executable makes for really good living documentation. Like, imagine having PRs where you could see visually how your app logic has been updated in that PR. It makes for a really logical source of truth because more people can understand it as well, and it's easy to be kept up to date. So going back to the problems that we have in state management, we have the modular and hierarchical structures in state charts. They handle complexity a lot better. We have the explicitness and clarity that makes complexity much easier to understand. And the visual representation is great for internal documentation. And we have a very clear structure for testing and debugging. So do you always need a state machine? Well, no. Like, especially if you have very simple and linear logic. I mean, if you're the kind of person who's still using Booleans for state, then you're not going to be wanting to use this. Maybe if you have very small and isolated components, the actor model might be really cool for you, but state machines might be a bit much and a bit unnecessary. When do you need a state machine? Well, the rest of the time, because complex systems are made much more simple. When you want to make it easier to document and to debug and to test, when you need to be able to communicate your logic and share one source of truth with the rest of your team. And returning to this sleep machine, like, this is a really basic demo, but it shows that your code can be much easier to understand and share at a glance when it's visualized. I don't know how often you find it when you've just been looking at the same code for such a long amount of time. Being able to see it in a different way is kind of in itself a form of rubber ducking. You can see how it is represented in a different space. And you can still write it as code if you like. And so all of this is just built on top of XState. XState has been a library that's been working without visualization for a long time. You have state machines as JSON objects or even just objects, essentially, so they're really easy to interact with and to use. You don't necessarily even have to use them with JavaScript. You could end up exporting them to other environments as well. But visually, it's still shareable with the rest of the team, and that's what makes it so valuable. And imagine if everyone that you're working with could collaborate on building the logic with the diagrams. Now, I suppose for a lot of you, that's probably a nightmare because you want to maintain control. But being able to explain it to someone and give them the power to feel like they understand it is incredibly valuable. And you still get requirements that can then translate very easily into code. Or you can very easily show people where issues might lie in their requirements based on your visualizations. And these models are really easy to test against. So in Stately, we've actually got something that's really basic right now, but it gives you the ability to generate test paths from your state machines, which can really speed up a lot of your model-based testing situations. So how about state machines as a source of truth? Now, I work for Stately, but I don't really mind if you don't use XState or Stately. But I feel like everyone gets a better night's sleep with state machines, including Oscar. Thank you very much. I'll be around for the rest of the day. It's lovely to be here.
I just want to look at pictures of the dog all day. It was a fantastic talk. We do have some time for questions, just about a minute. So, folks, okay, let me.
Laura, I was just wondering, could you quickly possibly show us, oh, you've unplugged your computer.
I can plug it back in if there's something in particular you want to see.
If you could quickly show us maybe what the JSON looks like, and also, I believe the source code for your example is available. Where can we find that?
Good questions. I will post that on social media because it will be easier than me trying to find it on my machine right now. But yeah, I can do that on there. I think it will be quicker than trying to locate it on this machine.
Okay. Any other questions? I just got to comment. I love the fact that you used PartyKit. I know
great.
Sunil. It's Sunil's the one that did PartyKit. It's built on Cloudflare workers. I was just talking to Sunil. He's like, yeah, I get to take credit for your code. So it's like, good. But that was fantastic. I loved the demo. Absolutely excellent. Thank you.
Yeah, I would say try PartyKit out. It's really good.
Yeah. All right, another round of applause. Laura?